Now, to review, since we've done this technically before in intermediate algebra, when you're solving systems of equations, you can do it by graphing like we did in the last section. However, graphing, when you're solving systems of equations, can give you a visual of where your answer is and what it might look like, but it doesn't always allow you to get the exact point. Now, on the three problems here on the left, when you have a 1 in front of one of your variables like this, it's easiest to use substitution. Now, on the problems over here, you don't have a 1 in front of any of your variables, so then elimination is often easiest. We would say over here in the red, when you have a 1 in front of one of your variables, substitution is typically the easiest because when you get your variable on one side by itself, you don't have to divide by anything and don't have to deal with fractions. So we're going to go ahead and solve this one here. We're going to take this y, which is already by itself, and then plug it in right here. So I'm going to rewrite the second one. X minus my input is equal to negative 14. Then I got to take what was y up above and plug it in down below. And then all I have to do is just go ahead and solve it. Now you need to remember to distribute through that negative into the parentheses. And then all we do is solve it. Combine our like terms, we get 2 of the x's. Then we can go ahead and take 6 and add it to the other side to undo it. And that gives us, let's see, minus 8. And then we divide by 2, and that gives us minus 4. And then remember, we're looking for the coordinates of a point, so we need to find the y. So I'm going to go ahead and take my minus 4 and plug it in right here to find y. My x is minus 4, I got to add 6, and I get then 2. So my answer I need to write as the coordinates of a point. Remember, your coordinates are always x, y. So it's my x right here, negative 4, followed by my y right here, which is 2. So on a problem like this, we could just plug it in. Now we can do the same thing right here. We got y by itself. All I have to do is just take it and plug it right there. So I'm going to plug that in there. Equals the rest of this right here. And then all I have to do is solve it for x. So I'm going to add 4 x's to both sides, so it gives me 12 of the x's, plus 6 is equal to 6. Get rid of that plus 6 by subtracting a 6 from both sides, and I end up getting 0. Get x totally by itself by dividing by 12, and I get 0. Now, you can plug your x being 0 into either one of those equations up above to be able to find y. It does not make a difference. If we go ahead and plug in right here, we would get y to be 8 times our input of 0 plus 6, which is 6. So remember, your answer is the coordinates of a point. It's your x, which is 0, followed by your y, which is 6. Even down here in this one, we need to do the same thing. However, we need, because we have a 1 in front of this x here, we're going to try to get that one where x is by itself. So to get x by itself, I need to get rid of my minus 5y, so I'm going to add a 5y to both sides. Since x is by itself, all I have to do then is take this and plug it into my other equation right there. So I'll write down my other equation, leaving a spot for my x to plug in. Plugging in my x in that spot, 5y plus 5, and then all I have to do is distribute through and solve it for y. So if I distribute through, still with that plus 4y is equal to minus 20. And then I combine my y's together on the left side because these are like terms, and I get a minus 16. Y, still with that minus 20, is equal to a negative 20. To undo my minus 20 here, I got to add 20 to both sides. I get a minus 16y is equal to 0. Get rid of timesing by negative 16, so I divide. I get y to be 0. Now, the easiest place to be able to find x is to plug it in right here. We just figured out y to be 0, so I'm going to go x equals 5 times my input of 0 and add 5. And then when I do that, I get x to be 5. Now remember, your answer once again is your x, which we just figured out, which is that red 5, comma, your y, which is that blue 0 down below. On these problems, if I needed to try to solve any of these for x or any of these for y, I'd have to eventually divide by something that's in front of my x or my y, and then I'd end up with fractions. Can it be done that way? Yes. Is it typically easy to do that way? No. Now, you will notice when we look at this first one here that the number in front of our x's are the exact opposite. The same number, but one positive, one negative. That is always nice. So then when we go ahead, all we have to do really is just add these equations together. So we're going to add our x's together. Well, they drop out. Then all we have to do is add our y's together. Negative 7y plus 3y is minus 4y. On the other side of the equal sign, we add those together. And then that gives us 4. And then we get y by itself by dividing both sides by negative 4, and we get minus 1. Then to find our x, all we have to do is take our negative 1 and plug it into either one of our top equations. I'm going to choose the bottom equation for no particular reason. Plug in our y, and then all we have to do is solve it for x. So I'm going to add 3 to both sides, and then I'm going to have to get x totally by itself by dividing by 0, and I get 0. So remember, your answer is always coordinates of a point, which is your x followed by your y. Our x was 0, and our y is minus 1. But when you look at problem number 30, we don't have the same number in front of our x's or the same number in front of our y's. So we need to do some adjustments. Multiply one or both equations by something so that we can go ahead and get opposite numbers. It doesn't make a difference which one. I'm going to go ahead and try to get rid of the x's. So I need to think of a number that 4 and 6 will both multiply into. Now, I'm going to realize that 4 times 3 is a 12, and 6 times 2 is a 12. So I'm going to try to get what's in front of my x's to be opposite. So one of them I need to have as positive 12. One of them I need to have as a negative 12. So I'm going to multiply both sides of this top one by a negative 3. And when I do that, I get a 12x plus a 21y is equal to a negative 24. Now remember, I want to try to get the same number in front of my x, but opposite. So I'm going to multiply this one then by a positive 2, because that gives me a negative 12 in front of my x's. So if I multiply everything by that 2, I would get this. Then, it's just like the last problem. I can just add down. Now in this case, when I add down, my x's drop. I add my y's. I get 1y. I add over here on the right-hand side, I get minus 4. So now I can plug in my minus 4 into any one of the original equations to find x. I'm going to go ahead and, for no particular reason, choose this one here. So it's a minus 6x minus 10 times my y is equal to 10, and I'm plugging in my y, which I just figured out. And so then when I do that, I get a minus 6x plus 40 is equal to 10. Subtract 40 from both sides, so I get a minus 30. Then all I have to do is divide by my negative 6, and I get 5. And then once again, remember your answer is coordinates of a point. So it's always your x followed by your y. So here we have a word problem. Typically with word problems, you want to let your variable represent what you're looking for. Well, we're looking for the price of an adult ticket. So I'm going to let that be A. We're also looking for the price of a child's ticket, so I'm going to let that be C. So now we have a couple situations here. We have one day where we have 2 adult tickets, and we have 4 child tickets, and we get a total of $36. Now, to figure out how much money you get from the adults, you got to take the number of tickets times your price, which was A, because we don't know that. To figure out from your child's, it's the number of tickets times your price, which is C, which we didn't know. Well, we need to do the exact same thing for our other situation, which is right here. And so we have 11 adult tickets, plus we have 3 child tickets to end up with $141. And so once again, you got to take 11 adult tickets times your price, which is A, and you need to take your 3 child tickets times C, and then you need to go ahead and solve this system of equations so that you can answer the question. Now, for me, I notice that the top equation, everything up here is even. So I'm going to divide everything by 2. So then I get A plus 2C is equal to 18. I notice that I can get A on one side by itself, so I could use substitution. Now, if I do that, I would get A is equal to a minus 2C plus an 18. And then I can go ahead and plug it in right here. Now, could you have used elimination on the 2 original equations? Yes, absolutely. Does not make a difference. Either one will work. I just noticed that we could use substitution because I won't have to end up having any fractions to deal with. So I can go 11 times my A plus my 3C is equal to this. Plugging in that A value, minus 2C plus an 18. Then all I have to do is go ahead and distribute through. Which is 198. Then I can put my C's together on the left side of the equal sign, and that gives me a minus 19C with my 198 is equal to 144. Then I can go ahead and subtract my 198 from both sides, so 144 minus 198, and I get minus 54, and divide it by negative 19, and I wonder if I made a mistake. Yep, my mistake is I rewrote this as a 44. So if I get rid of that and fix it, that's a 1, 1, 1. And then when I subtract down here, I get a 57, negative. Then I divide, and I get 3. Because I just knew I couldn't have a fractional, not nicely to get a fractional price. So then I can plug it in right up here to be able to find out what my A is. And when I plug that in, I get A to be a minus 2 times my C. And I just figured that out to be a 3. So you get A to be a minus 6 plus 18. So I get A to be 12. So I'm going to write down adult tickets is $12. And then I need to answer this, and I'm going to write down child tickets, and that's $3. So with word problems, make sure you actually answer the question that's being asked.